Next speaker is going to be Melissa Wilson, and she is Associate Professor at the Department of Soil, Water, and Climate. Her research and extension programs are focused on manure and nutrient management and water quality. And if you know her at all, she's always full of enthusiasm and just a joy to work with. So she's going to be online, and we're going to be ready to go.
All right, so thanks everyone for sticking out through the storm. For those of you who are in person, for those of you who are online, sounds like maybe a good choice, as it's gonna get bad here pretty quick. So I want to talk a little bit today about manure as a source of nutrients in an era of expensive inorganic fertilizers. I'm going to excuse myself today. I actually have a lot of ideas on the topic, so I'm going to try to stick to my 40 minutes. But excuse me if I'm moving quickly. I'm just pretty excited about talking about manure. So first off, I want to talk about why it's a valuable resource. We often think of it as a fertilizer for nitrogen, phosphorus, and potassium, but it also has all of the nutrients that a plant needs because animals are eating plants, and then what goes in must come out. So we're getting all of the secondary and micronutrients as well. The second reason that manure is such a great resource is because it's also a soil health amendment. Along with all those nutrients, we're getting carbon coming with it too. So we're returning carbon to the soil, which then can degrade and supply all of the nutrients as well as carbon that the soil organisms need to. And in fact, some of the recent research has shown that it can improve aggregate stability, it can improve water holding capacity of soils, and so on and so forth. So lots of evidence that when applied at the appropriate rates, it can be a soil health amendment. And then finally, I always like to think of it as being locally produced. So I have my little made in the USA sticker here. So that's one of the great things about manure is that it's a local source. And as long as we can get it back into our systems and supplying nutrients that are then going into the crops and then fed to our animals, it can be a really nice circular process. But manure is more complicated than fertilizers. And that's one of the reasons why sometimes people have trouble wanting to use it, so to speak. We know that nutrient availability is really variable. We know that nutrient ratios do not always match plant needs, and we'll talk a little bit about that in more detail. And then oftentimes it's stinky and people don't want to deal with it, so they see it as a waste and not necessarily as a resource. And kind of because of all of these reasons, sometimes these uncertainties can lead to over-application. Whether it's because they want to reduce the risk of not having enough nutrient availability in any given year, or because it's a waste and they just want to get rid of it. They don't want to have to move it to more fields. They just want to be able to apply it and be done with it. So we have to think about, especially as these fertilizer prices are really high and we're wanting to replace those nutrients, we really think of what we need to do to get the best bang for your buck, so to speak, from manure. So I kind of have three different topics I want to talk about when it comes to getting the most value. First is going to be getting your manure sampled and tested regularly. Then we'll get into how to choose the fields where you can get the full benefit of manure and walk through some scenarios. And then we're going to talk about using BMPs to keep the nutrients in place. Like once you get them to your field, sometimes they have a long time before the crops are going to take them up. So you need to figure out how to best keep the nutrients where you put them. So first up, I want to talk about sampling and why it's really important to sample our manure regularly. And I'm going to do that by showing you some data of manure samples taken all over the state. So we actually partnered with 3 different labs that operate here in Minnesota, and they shared all of their manure data with us from 2012 to 2021. So we are reaching back out to get the 2022 data in here as well. But this is what we have so far. What I'm going to show you is the nutrient content. If it's a solid manure, it'll be in pounds of nutrient per ton, or if it's a liquid manure, it'll be in pounds per 1,000 gallons. So in this first one I'm going to show you is a swine liquid manure. Down here we have the number of samples, 49,000 samples as represented in this data. So it's pretty significant. And then each of the nutrients is shown here in a different symbol. So the circle red symbol here is the total nitrogen content. The lighter red diamond is the ammonium nitrogen, and this is part of the total nitrogen, but it's considered the plant available portion. We also have phosphorus as P2O5 in the yellow triangle, and potassium is K2O in the gray square. Then you'll see these error bars on either side. So the values where the symbols are shows you the median value, or kind of like the average nutrient content that you can expect. But the error bars shows you the middle 50% of all of the samples. So it really gives you a good average range of what you can expect, but it leaves out all of the outliers. Like when you got a sample that says it has no nitrogen or it has 1,000 pounds of nitrogen per 1,000 gallons. We do see that, but those are really uncharacteristic. So what I'm showing you is what we can kind of expect. So this is swine liquid. Here we have our poultry solids. We have a little under 10,000 samples represented. Then we have our beef solid manures, about 5,000 samples. And we have our liquid dairy manures, a little over 10,000 samples there. So a couple things you probably noticed right away are swine, liquid, and poultry solids tend to have a lot more nutrients per unit of manure compared to beef or dairy. And that doesn't necessarily mean that beef and dairy are worse manures. You just have to apply more of them to get the same nutrient content. The other thing that I like to point out, especially for swine and poultry, we see a really big variation in the nutrient contents. Some of this is because of the way these animals are raised. Like swine, for instance, has the different categories, where you have nurseries, you'll have finishers, that sort of thing. And because of that, we can see wide swings in the different manure nutrient contents. But again, it's really important to sample, because if you think you have this median value, say you think you have 45 pounds of nitrogen in your swine manure, but you actually have 60, you're going to be over applying your nutrients. And in that case, especially when fertilizer prices are high, we don't want to be doing that. We want to be spreading the nutrients on as many fields as possible. But on the other hand, if you think you have 45 pounds of nitrogen, but you only actually have 30, you're going to be significantly under applying nutrients, and you're going to see nitrogen deficiencies in your corn. So again, really important to sample manures to know what exactly you're working with. And if you're a livestock operation, it's certainly good to do this. If you have consistent feed, consistent watering methods, consistent handling, everything, you can probably get away with doing this every 3 to 4 years once you establish a baseline of consistent samples. But if you're changing feed, if you got a new watering system, that sort of thing, you might want to measure again after you've done that, or more frequently if you're frequently changing these things, because this will affect what the nutrient content looks like. If you're someone who doesn't have livestock, but you're getting manure from a livestock owner, ask if they have a recent manure nutrient analysis. And if they don't, definitely get one as it's being applied that year. I'm not going to go too far into sampling. We do have some resources online for you to check out. I believe these slides will be available afterwards, so you can then click on the links instead of having to try to take your phone and take a photo of this now. So this will be shared at a later time, but definitely check out our University of Minnesota Manure YouTube page for some of these things. The other thing I want to point out is where to send your samples. We actually have a manure analysis proficiency program that is nationwide for all labs to participate in, to make sure that their equipment that they're using, as well as their methodology, is working consistently across all their different manure sample types. And the program is actually run by the Minnesota Department of Agriculture. This is the only program in the entire nation that does this, and it's in our department, it's in our state, so that's kind of cool. And they have two programs, the Manure Analysis Proficiency Program, and then the Manure Testing Certification Program. So labs will participate usually at least in this first one, the Manure Analysis Proficiency Program, and then some opt to test or go into the certification program, which is actually a little more strict, where their test results are really looked at pretty closely. So again, here's a link to that, where they'll have a list of all the labs in every state that are going through this program. So check them out. You'll definitely see that these labs tend to have more consistent results when they're looking at manure analyses. And manure isn't exactly something that's really easy to test. It does have certain implications with all the carbon and everything else that's added into it. So certification program or the proficiency program is definitely something you want to look into. All right, so we know testing is important. The next thing to really think about is where can we get manure applied that gets us the most bang for our buck? As I mentioned before, manure is a really good nutrient source for a lot of different nutrients. This diagram, I believe the United Soybean Board put this together. Here they have the different animal species up top, and then they show the relative size of the nutrient content or organic matter content in the manure. So a smaller square, for instance, means it's a lower content, a bigger square means it's a higher content. So for instance, poultry has a really big calcium square because they feed a lot of calcium to the birds to make sure that they get really strong eggs. So it's really kind of interesting to see how the nutrients play out relative to one another in the different species. And as I've said before, what goes in must come out. So everything that plants need that they take up then goes into the feed of the animals, and then it has to come back out. So it's a really good nutrient source in that way. The one thing that can be kind of tricky though is the manure nutrient ratios. The ratio of nutrients in manure, particularly the nitrogen to phosphorus, is going to be really important. Plants take up roughly 5 units of nitrogen for every unit of phosphorus. And this ratio varies depending on the type of crop we're talking about, but on average, we're going to roughly assume a 5-to-1 ratio. The available nitrogen to phosphorus ratio, however, really depends. For instance, for swine, say I assumed that we were going to apply swine manure with the best case scenario, we're going to get the most nitrogen from it. So I assumed an availability of like 80%. And then we made assumptions about availability of phosphorus being about 80% as well. So overall, for every unit of phosphorus in swine manure, we're going to get about 4 units of nitrogen. So the ratio is close to what a plant needs, but it's not quite there. With beef cattle, it's about a 2-to-1 ratio, 2 units of nitrogen to 1 unit phosphorus. With dairy cattle, it's a 3-to-1 ratio. They typically have a little more nitrogen in them. The diets tend to be pretty high in protein, so high in nitrogen is coming out of the back end. And then with poultry, it's about a 2-to-1 ratio as well. So if I convert these all, like these are all based on a phosphorus being 1 ratio. If I change it all to a ratio of 5 units of nitrogen to see how many units of phosphorus we get, this is what that looks like. For swine, say it's a ratio of 5 units of nitrogen to 1.25 units of phosphorus. So if you're applying manure every year, you're going to be potentially applying a little bit more phosphorus than you need. With beef cattle, it's 5 to 2.5, and it's the same for the poultry as well. So in that case, you're potentially over applying a lot more phosphorus than you might need. And with dairy cattle, it's a ratio of 5 to 1.7. So again, you're potentially over applying phosphorus if you're applying manure every year for these crops. Now, if you consider maybe a corn soybean rotation where you wouldn't be necessarily applying nitrogen, but you would be looking for more phosphorus, say that ups our N to P ratio needs to be 5 to 2. In that case, for swine manure, we're going to be a little under, so you probably need to apply more phosphorus fertilizer. For beef cattle and poultry, we're probably still going to be over applying phosphorus in that case. In dairy manure, we're actually getting pretty close at 5 to 1.7. So again, these ratios are all going to be not exact, just kind of giving you an example of thinking about how these ratios are actually going to be important when thinking about balancing out your nutrients going forward. Here's just an example of that. This is, we are working with a farmer in Maryland. I worked there previously, working on manure management plans. And we gave him our scenario where he had a field and he was trying to decide, does he want to apply his manure on a nitrogen-based rate or on a phosphorus-based rate? So that's kind of the 2 scenarios that you see here. Nitrogen-based rate is this first graph on the left, We see the nitrogen needs of the crop, the phosphorus needs, and the potash. And the black outline shows you how much of the corn crop needs based on soil test or the guidelines for the state. So in this case, there's a nitrogen credit here of about 10 to 15 pounds of nitrogen from a previous manure application. And then the farmer wanted to apply the rest of his nitrogen needs with manure. So you see that being met in yellow here with the manure. Now with phosphorus, you see that basically over applied phosphorus by double, and they even over applied the potash a little bit as well too, just because that's the ratio that came with the manure. Now, why this is important is because in Maryland specifically, they have really strict guidelines on what soil phosphorus tests can be. If they become over a certain level, at that point, you can no longer apply for their phosphorus sources, meaning manure. So farmers have to be really careful to make sure that they're not building up their soil phosphorus tests too high. So in that case, we said, if you are trying to not build your phosphorus any further, you'll probably want to choose a phosphorus-based manure application rate. So then you'll see how much of the nitrogen and phosphorus or potash was applied by the manure. So the blue in these two boxes represents the fertilizer needs that would need to be applied after the fact. So again, kind of two options for the farmer to consider. In one case, they're supplying all the nitrogen needs with the manure, but possibly over applying phosphorus and potash. In the other case, maybe they can spread manure on more land and get benefits that way, but then they'll need to balance out the nutrient needs with fertilizers. And then here's just one crazy example that we ran into. And this is actually a real case of something that happened to us. This is another farmer who wanted to import chicken litter from Pennsylvania over the border into Maryland. And the nutrient needs of the crop were 200 pounds of nitrogen, 47 pounds of P2O5, and 52 pounds of K2O. He was applying enough or bringing enough poultry litter over the border that he wanted to apply 5 tons per acre into no-till. No-till meaning that they were not going to incorporate the manure. We got the nitrogen test back and multiplied it out to see how much nitrogen was going to be applied at 5 tons per acre. And it was 151 pounds of nitrogen, which is reasonable, but it was 426 pounds of P2O5 and 421 pounds of potash. It was a really incredibly high amount of phosphorus and potassium as well. So if you look at the recommendations, again, the black boxes show you what the needs were of the crop. And then the yellow shows you what was being applied with manure. And in this case, they weren't actually applying the full nitrogen needs of the manure. They still needed to apply a little more nitrogen. But you can see the phosphorus and potassium were over applied by like 10 times. And in this case, this is really exceptional because this is how you go from not being regulated in Maryland to being regulated for decades and not being able to apply any further P sources. So we certainly recommended, backing off that application rate on these fields rather than going with such a high application rate. One of the interesting things is we called the lab to make sure that there wasn't some typo, and there wasn't. They had actually run it twice to double check to see if this was correct. And the nitrogen levels were actually pretty standard. They were somewhere between 50 and 60 pounds of nitrogen per ton for total nitrogen, which is what we see here in Minnesota for turkey litter. It was just the phosphorus and the potash were just out of the range for some reason. I don't know what they're feeding the birds to get that high of P and K, but certainly can probably look at the feed side of things and see if they can back off phosphorus in those diets. All right, so moving on and thinking about, so we talked about what's in the manure. The other thing we need to consider is what's already in the soil, what's already in your phosphorus bank, your potassium bank, so to speak. If you have soil tests that are low or very low, and you want to try to build soil phosphorus levels, maybe this over application of phosphorus isn't that big of a deal if we're only bringing it up by a few parts per million here every couple of years or so, because in that case, that can be beneficial. But if you're already soil testing your phosphorus and potassium levels at really high or very high, maybe there's better fields where you can actually get the value of manure where the value of the manure can actually be used better. So this case, I put together some scenarios looking at the value of manure, and I'm mostly going to focus on the NPK for the corn soybean rotation. I'm not even necessarily going to touch upon the secondary and micronutrients. So in this case, we have a livestock barn up in the northeastern corner of this map here. And they have two fields where they're thinking about applying manure. Say field 1 is right next to the barn. It's historically where the manure has been applied. So we have really high testing phosphorus and soil test K as well. And then about 4.5 miles away, they have their second field. And it needs a little bit more phosphorus and potassium, particularly when you consider the corn soybean rotation. So these numbers here for field 1, it needs 150 pounds of nitrogen. And because of the high soil test phosphorus and potassium, it doesn't actually need anything for the soybean or the corn for that. In field 2, it still needs 150 pounds of nitrogen, but the soil test levels suggest that 150 pounds will be needed for both the corn and the soybean, and 140 pounds of K will be needed for the corn and soybeans as well. One of the things that people often think of is like, there's no way I'm hauling manure 4.5 miles. That's going to cost too much, and they won't even necessarily consider it. So one of the things that we like to do is try to do some really rough calculations, like how much is this actually going to cost? So say for our full nitrogen rate, we're going to apply 4,500 gallons of the swine finishing manure per acre. And we assume some cost. So I work with a lot of commercial manure haulers in the state and always get varied responses. But let's say on average, it's going to cost about 1.5 cents per mile to haul manure up to a mile. And then after that, we're going to add a 0.4 cent surcharge for every mile after that. So the cost then, in this case, will be about $67 per acre for the field 1 right near the barn, so that's within a mile. And then for field 2, once we add on all the surcharges for the extra 3.5 miles beyond the first 1 mile, it's going to cost $130.50 per acre to apply that manure. So in that case, a lot of people are like, why would I double my costs for applying the manure? It's like they don't think it's necessarily going to be worth it. But when we're thinking about the actual value of manure, with the nitrogen comes the phosphorus and the potassium as well. So in this case, 4,500 gallons is going to supply, on average, 150 pounds of nitrogen, and this is first year available nitrogen, 99 pounds of phosphorus, and 144 pounds of K2O. I assume that the P and the K were 100% available over the 2 years. We usually assume about 80% availability for phosphorus in the first year and 90% for potassium, but over the 2 years, we assume it'll all be available. For the swine manure, we assumed we'll be injecting it. So about 70% of that total nitrogen is available the first year. And because we're in a corn soybean rotation, we're not valuing the second year nitrogen credit in this particular case. So let's take a look at the values. So for field 1, I made some assumptions here. I talked to Bill before this and had him help me work out the fertilizer prices. But right now, nitrogen is about 85 cents per pound of nitrogen. Phosphorus is about 69 cents per pound of P2O5. And potassium is about 65 cents per pound of K2O. So when we think about the value of manure in field 1, the value is really just in the nitrogen. We're not getting a value from the phosphorus. We're not getting a value from the potassium. We're applying it. We're just not getting any value from it. So in this case, the nitrogen replacement value is $127.50. You're not paying for that in fertilizer, and therefore you're replacing that with manure and getting the value that way. Now, when we subtract out application costs of $67.50, overall, our replacement value is about $60 per acre. So that's with field 1. With field 2, we're assuming that we are getting the value from the P and the K. So for nitrogen, we're still getting the $127.50 per acre. For P, we're getting 99 pounds of phosphorus. Do remember that that's not quite the full needs of the phosphorus, so you will still need to apply some fertilizer, so I'm not counting that. But we did save $68.31 in replacement value for not having to apply the full rate as fertilizer. And then for potassium, in that case, we needed 140 pounds of nitrogen, but the manure was supplying 144. Since we're not valuing that extra 4 pounds, I only took the credit for the 140 pounds that was needed in this particular field. So overall, that was about $91. So when you add all these up, subtract out the higher application cost of $130.50, you're actually getting $156.31 in replacement value for that manure. And that's with hauling it or an extra 3.5 miles or 4.5 miles away. I actually did the calculations. This is of course just based on this particular scenario, but we could have hauled this manure up to 9 miles and still had a higher replacement fertilizer value than field 1, which is right by the barn. Going to the 10th mile does actually reduce the cost to below the $60, but it really goes to show that hauling is not as expensive as people think if you are getting more value from the phosphorus and potassium of the manure. So it's just something to think about. All right, best management practices. We talked about testing your manure. We talked about thinking about where you're applying it so you can get the best bang for your buck. And I want to finish off with thinking about how to keep it in place once we've applied it. So I like to talk about the 4 R's of manure management, same as with fertilizer. It's the right source, right rate, right place, and right time. For the right source, of course, it's manure. That's what we're talking about here. But a lot of times people forget to think about the other nutrient sources altogether. So you have to think about, are you applying starter fertilizer? Does it have nitrogen in it? Are you thinking about irrigation water? Some irrigation water has a significant amount of nitrate in it, which you could reduce your application rates because of that. And then thinking about previous nitrogen credits is important as well. Are you coming out of alfalfa? Are you coming out of dry beans, something that provides nitrogen credits, that sort of thing? Thinking about all of these together is going to be important when considering the right source. Next up, I'm going to talk about right rate and right place. In manure, these kind of go together because the place that you put it in the soil is going to determine what the actual rate is. So here we have our nitrogen availability factors for different manure types. We have beef, dairy, swine, and poultry. And then we have the availability factor for the first year after application and the second year after application. So animal species plays an important role, and we'll talk about why in a minute. But the other thing that plays an important role is how we're incorporating it, AKA the right place. So if we're injecting it, so getting it underneath the soil surface immediately, that's where you're getting the best bang for your buck, especially when it's a liquid manure. If it's a solid manure or liquid and you're broadcasting it, the faster you get it incorporated, the more nitrogen you're going to preserve. So you'll notice the availability factors are the highest if you get it incorporated within less than 12 hours, and then they slowly decline from there. And you'll see the losses increase the longer it takes to get it incorporated. Now, the reason for that is because of the way nitrogen is excreted from the animals. So what I have here is a bunch of summary data showing you the percent of total nitrogen. If the total nitrogen is in the organic nitrogen form, so bound to carbon, it's shown here in yellow. If the nitrogen is in the inorganic plant available form, in this case, it's mostly ammonium, it's going to be shown here in red, and then the percentages are listed in red here as well. So what I've done is I separated it into different manure storage types, so liquid and solid, and then we have the different species, swine, dairy, beef for the liquids, and swine, dairy, beef, and poultry for the solids. You'll notice that the liquid storage systems tend to have a lot more ammonium compared to the organic nitrogen. For dairy and beef, it's about 50-50. For swine, it's actually about 75% ammonium. In some cases, I've actually seen barns that were 80 to 90% ammonium. So in this case, that's why getting liquid manures incorporated is going to be especially important for preserving the nitrogen. For our solid manures, they're a much lower percentage of ammonium. Like dairy and beef especially are less than 15%. Swine is a little higher at 20%, and poultry is a little higher at 26%. So these definitely want to get incorporated because you don't want to just lose 15, 20, 26% of your nitrogen, but it's not quite as critical as it is with our liquid manures. And when I say lost, I'm mainly talking about ammonia volatilization, so gaseous losses, because that's what happens when the manure is broadcast on the surface and interacts with the atmosphere. This nitrogen can quickly turn into a gas. And just to show you some of the percent ammonia losses compared to application methods, we see that surface application, if it's a solid, we may lose 15 to 30% of that total ammonium. Of our liquids, it might be 10 to 25%. The liquids are a little lower because liquids will infiltrate into the ground. The solids just sit on the surface and they don't incorporate quite as quickly into the ground. So you'll see pretty high losses with those. If you incorporate it, and this is incorporation within a couple of days after application, it's 1 to 5% losses. Injection in this study they found was anywhere between 0 and 3% loss. And then they did look at irrigation as well, and that was really high, 30 to 40%, because in that case it's flying through the atmosphere and then landing on the ground. So unfortunately, a lot of ammonia can be lost in that way. So overall, the whole point of talking about this is to make sure to cover up your manure during application or as soon as possible afterwards to preserve your nitrogen. Again, in these times with high fertilizer prices, we want to keep the nitrogen in place and not in the atmosphere to try to get the best bang for our buck. Now moving on to right time. We know that about 65% of manure is applied in the fall in Minnesota. Some of the recent survey work done looking at nitrogen fertilizer use and manure use has shown that the majority of manure is put on in the fall. One of the important things that's going to play a role here is soil temperatures. They play a big role in preserving nutrients. I also want to touch a little bit upon nitrification inhibitors because these can help, but it depends, and we'll talk about that. So first off, I want to talk about a study that we did that looked at manure application timing and cover crops in 3 different crop rotations. I'm not going to focus on the cover crop talk or piece of this here. I'm going to mostly focus on the application timing. So I wanted to show you green yields. So this is corn following sweet corn. So we grew sweet corn, planted cover crops, applied manure, and then followed it up with a green corn. And this is the yield from that following green corn. What we did is we compared late October, 2 different timings for fall manure, late September. So in this case is mid to late September. Soil temperatures were still really warm. We compared that to late October manure application. Soil temperatures were much cooler then. And overall, our control then was a spring fertilizer, pre-plant fertilizer treatment. So what's typically done in this region. So we actually had kind of different results in 2020 and 2021. Remember, 2020 was kind of a normal year. 2021 was a bit drier. It was a little bit of a drought that year. But we were pretty surprised with our fertilizer treatments. We averaged about 230 bushels per acre. And that's a pretty typical yield that we're seeing at this site. This is southern Minnesota near Waseca, Minnesota. And compared to our late September manure, which is our early fall manure, our spring fertilizer did a lot better. We actually saw like 10 to 13 bushel per acre yield losses, 10 to 14, yield losses when we applied the manure too early. When we applied the manure in later fall, in 1 year, 2020, we actually got significantly higher yield than our fertilizer treatment. In fact, by 33 bushels per acre. It was our highest yields that we saw that year. In 2021, when we had the drought year, the yield was slightly lower than our fertilizer plots, but statistically, see all the bars that have the same letters above them are not different. Statistically, this was not different. There was enough variability that it wasn't statistically significantly different. So it's kind of interesting. We think that what happened is 2020 was more of an ideal growing season. So the manure was able to mineralize a lot of the nitrogen and some of the other micronutrients and stuff too. And that's why we think we see such a yield bump in the 1 year. In 2020, when it was dry, you know, the microbes that are breaking down the manure rely on good growing conditions, just like the plants do. And because it was a little bit drier than normal, maybe it didn't mineralize as much as our fertilizer plots did, which are already fully nitrogen available. So overall, we're pretty pleased to see that late manure application was still behaving similarly or better than spring fertilizer, but the early manure application, especially with the swine manure in this case, it's really, you're going to lose nitrogen and it's going to affect your yield. So we did a very similar study in a silage corn system. We used dairy manure in this case, and we got the manure in the early fall applied a little bit later. So this is more of an early October manure. Soil temperatures were still warm, but not quite as warm as they were in September. And then we also applied late October again when soil temperatures were cool, and compared that to spring fertilizer. In this case, both of our manure applications, whether it was early October or late, are pretty similar at around 26 tons per acre. And then our fertilizer ended up being around 24 tons per acre. So manure in this case, when it was dairy manure, which typically has a lower ammonia content, was not as affected by the timing quite as strongly as the swine manure was. But overall, we're pretty glad to see that manure was serving as a really good nutrient source, especially compared to the fertilizers. So what's the main thing happening here? Why are we seeing some of these losses? Well, a lot of it has to do with the soil temperatures. There's been a lot of studies showing that soil temperature really impacts nitrification. Nitrification is the process of converting ammonium nitrogen into nitrate nitrogen. Nitrate nitrogen is the one that can be lost via leaching. It can be denitrified, turned back into a gas. So there's a lot of reasons why one would prefer to keep nitrogen in the ammonium form. So this graphic here, this is a research done. It shows percent nitrification, so 0 of the ammonia nitrified up to 100%. And then it shows you time from 0 to 12 weeks. Each of these different lines is soil that was held at a different temperature. So at 75 degrees, 100% of the ammonium nitrified within 2 weeks. When the temperature was brought down to 50, most of it still nitrified, but it took 12 weeks. At 45 degrees, a smaller percentage was nitrified. At 40 degrees, even less was nitrified. And at 35 degrees, very little was nitrified. I want to point out that it's not 0. There's not 0 that nitrified at 35 degrees, which is just barely above freezing. Nitrification is still happening even at these really cool temperatures, but it is very much slowed. Of course, I always like to look at this in our own studies as well. We figured, oh, let's just try it ourselves. So we actually got some soils. Some had dairy manure in them, some had swine manure. And we put them in some jars, and some of the jars we put in a refrigerator, some of the jars we kept out on the counter. And after about 28 days, we came back and measured the ammonium and nitrate in the jars. So the first one here, you can see the red shows you the ammonium fraction of the nitrogen, and the yellow shows you the nitrate. So when our soils with the different manures, dairy or swine, were kept at 40 degrees, you can see that we had a lot higher proportion in the ammonia fraction than the nitrate fraction. When we kept it on the countertop, there was a lot less nitrogen total, because you can see that the total amount of nitrogen decreased for the dairy and the swine. And then there was barely any that was left in the ammonia fraction. It was primarily nitrate at that point. And we think that some of the losses that happened were probably gaseous losses, because obviously in a jar, they can't leach. So it really goes to show that temperature really does play an important role. All right, another question I always get is nitrification inhibitors with manure. One of my colleagues, Jeff Vetch, conducted a study. They looked at finishing swine manure and wanted to compare early manure. So they did early October, immediately after soybean harvest, And this is when soil temperatures were still warm. And compared it to early November when soil temperatures had become less than 50 degrees Fahrenheit. And then they tested 3 different rates of instinct: no instinct, a full rate, which is about 35 ounces per acre, and double the rate, which was 70 ounces per acre. And this is what it looked like for yield. They measured yield, or this is yield after manure had been applied in October or November. And then the first bar in each group is where no instinct was included. The middle bar is where the full typical rate was included. And then the yellow bar, the last one in each group, was the double rate. And then there's letters above each of these bars. If the letters are different, then we saw a statistical difference. So what we see is that in October, instinct helped increase yields statistically. But in November, they did not. There was a slight numerical increase, but you'll notice that the no instinct yield in November was pretty much the same as the instinct yield in October. So again, it goes to show that temperature is probably playing a bigger role here than using the instinct necessarily is. Now, if you have to get the instinct or manure applied early, like in October, instinct can help reduce some of the ammonia losses, and that's what we saw in this study. If you're waiting until November when the soil temperatures are cool, in that case, I don't know if it's paying off to pay for the instinct to only get very minimal increases in yield. So that's where instinct can be helpful. If you need to apply manure a little earlier in the fall due to logistical reasons, maybe this can help. So here's some of the take-home messages, kind of what we already talked about. Instinct did reduce nitrification in the soil. Does it pay off when you're waiting until soil temperatures are cool anyways? Maybe not. This was for swine manure. And in fact, the same study, pretty much the exact same study, was carried out in Iowa, and they found the exact same thing. With dairy manure, however, it may not work as well. Dr. Carrie Lebowski did a really big study. It was at 3 different sites over 3 different years at each site. And sometimes it worked and a lot of times it didn't. So they actually don't recommend nitrification inhibitors for dairy manure in Wisconsin. And some of this probably goes back to that graphic that I showed you earlier, where swine manure has a larger proportion of nitrogen in the ammonium form than dairy does. And, you know, these nitrification inhibitors are meant to work at keeping ammonia in the ammonia form. So it's probably why they're a little more effective for something like a swine manure, particularly if it has a high ammonia concentration. So to summarize, I like to think of the many layers of poo or many layers of manure. And so I added some little stinky signs here to my manure pile to let you know that that's manure. But my first point of the talk was to get manure tested regularly. Second important thing is to value manure as a complete nutrient source. You're going to get the most bang from your buck applying it to fields that need all of the nutrients, or at least more of the nutrients than fields that only need maybe nitrogen. Even if you can find a field that needs nitrogen and potassium, maybe soil test phosphorus is already high, but as long as you need at least 2 of the nutrients, you're still better off than just putting it on a field that only needs 1 of the nutrients. 3, cover it up to preserve nitrogen. Trying to get manure incorporated or injected as quickly as possible is going to preserve your nitrogen. And then finally, in fall, wait until soil temperatures are cool to apply. If you need to apply a little bit early, in some cases, particularly with liquid manure, with liquid swine manure, we've seen that inhibitors, nitrification inhibitors may help. But in other cases like dairy manure, they may not be as effective. So thank you. Thanks to some of the funding sources for some of the research that I showed you today. And if you have any questions and they don't get answered here today, feel free to contact me, follow me on Twitter, and check out some of our research. Thank you. Is there any questions? All right, is there a ratio between distance from farm field to manure source and the manure value? If you drive 50 miles round trip for manure, is it cost effective for corn? I think that's really going to depend on these nitrogen prices, right? When I talked about in this scenario that they could have hauled it up to 9 miles, that's really dependent upon the fertilizer prices or the replacement value that you're getting. In years where the fertilizer price is going to be a lot lower, then obviously that ratio of how far you can drive is probably going to be lower as well. So it's really going to depend on the particular economics and situation that you're talking about. It also depends on the manure, right? Different manures are going to be different, especially when we're thinking about application rate on top of everything as well. Next question, do you ever see our manure management planning to go from nitrogen-based to phosphorus-based? The findings on the East Coast slide today show some value to it, it seems. Yeah, that's a good question. When I worked in manure in Maryland, the history of that state was that they had been doing a lot of manure management plans, nitrogen-based, for a long time. And they actually had a really big algal bloom. It's called Pfiesteria. That was a toxic algal bloom that bloomed in the bay, and it killed off a lot of fisheries. So it was a huge disaster. And they actually found it was due to excess phosphorus in the water that caused this particular bloom. So that's kind of when they switched regulatorily to a phosphorus-based system where they're looking more at regulations based on phosphorus. If your soil test levels are low, then you can still apply on a nitrogen-based rate in Maryland. It's just once your tests get to a certain level, then you have to base it off of phosphorus or maybe not even apply manure at all. So, you know, if that's the way Maryland went, if we start seeing some of these issues going into the future where phosphorus starts becoming more of what we're trying to battle against in our waterways, then I could see it moving that way. But right now, I know we're pretty concerned about nitrogen in the state. So I see that staying in that way for a while.
All right. Let's give Melissa a hand.